E1. Guess what E1 stands for?
Elimination.
Elimination what?
Oh, the first
Mono.
order.
Mono.
Sorry.
Unimolecular.
Elimination unimoleculars. And this is like SN1, but instead of a substitution, it is an elimination. Which is the preferred alkyl halide? Tertiary. So if it is tertiary, what is it going to happen? Let's say this is the tertiary alkyl halide you have. What are all tertiary alkyl halides going to do?
Carbocation formation.
That is going to
Leaving
go,
group, yeah.
and you are going to form
A
the
carbocation.
carbocation. And this, of course, now it looks like this. Now, if there was a nucleophile, what would it do? It might come in there and substitute. Yes.
Right.
But if the nucleophile is a base, okay, or the nucleophile is basic, there is a possibility that instead of doing a substitution reaction, it's going to go here, and it is going to pull this hydrogen off. If it pulls the hydrogen off, what happens? If it pulls this hydrogen off, what is going to remain behind is
The lone pair.
these
Yeah.
two electrons. the
Yeah.
lone pair.
Gonna be
There's a
negative.
positive charge here. So what is going to happen is these two electrons will go and will make a double bond there.
Okay.
So
That's right.
from there, what you are going to get is an alkene. So the product of an elimination is an alkene. And once again, this is E1, so it follows like the SN1, the unimolecular process. Does it have anything to do with the amount of the base?
No,
No. Does it have anything to do with the amount of the nucleophile?
no.
No. The nucleophile is a base, yes? Hello?
Yes.
If it is E2, maybe I shouldn't draw it like this. Let's say this is a CH3, here's an H, CH3, and an H.
I'm confused. How do we know when it will do substitution and when it will do elimination?
So fun.
You don't.
But like it'll tell us when it has to do elimination.
Fun. Oh, no, no.
He's not laughing at you. Why would he laugh at you? It's just having a conversation on my camera over there. Yes, well, her question is a good question, okay? How do you know when it's going to do elimination or substitution? Tough question, right? Guess what happens?
Which is my question.
Substitution happens
Yeah,
and elimination
Mission
happens.
happens.
You can just control this slightly. When you use a base that is hindered, what does it like to do? Eliminations, okay? When you use something that is not very basic but a good nucleophile, what does it do? Substitutions. But you will get the other one, but it will be the minor product, okay? Normally, if on the test I want to force you to do an elimination or a substitution, because you can't tell what it is, I will tell you provide the elimination product or provide the substitution product. Okay? If you don't know, you ask me. So here, this is going to be an elimination, and this is E2. This is bimolecular. So here, the nucleophile is going to do what? The nucleophile is going to pull. This carbon here is called alpha,
Yeah, it's an alpha position.
and this one
It's called beta.
is called a beta carbon. Okay?
Uh-huh.
And if it had more carbons, you can just continue using the letters that you probably don't know about, right? After beta, what comes after beta?
Gamma.
Omega?
It's alpha because that's where it has the halogen group on it.
Yes, alpha is where the business end is.
Where the navy
And this is beta too, yes? This one is beta too. Hello?
Yeah.
Yeah, that's a beta position.
All right, whatever. So, what is this going to do? This is going to attack that proton. It's going to take it. And this electron pair is going to make a double bond here. And the leaving group is going to leave. All of this happens at the same time. So it is said that this
Concerted
mechanism is
Concerted.
concerted.
Yeah.
How many steps does that mechanism take place in?
One.
One single step. It is two reactant molecules, but one step.
Mm-hmm.
This one here occurred in how many steps?
Two.
In two. The first step is
The leaving group.
formation of the carbocation.
Yeah.
And the second step is
The nucleophile
The
attack,
nucleof-
or whatever.
the base
Base
or the nucleophile.
Deprotonated,
proton off.
right?
Mhm.
Deprotonated.
Deprotonate. Okay. Now this here is very specific. Okay. This has to be the elimination has to be anti-periplanar.
Anti-periplanar. Say that 5 times fast.
And anti means the anti you have from Newman projection. The hydrogen has to be on one side, and the bromine has to be at 180 degrees from that hydrogen. And that's called anti-periplanar. Means that it has to be on the same plane. Okay? Now some people call it coplanar. Since I learned when I was a baby, periplanar, that's what I use because it sounds fancy, yes? Anti-periplanar? Hello?
APP.
So how does this look in the Newman projection? How does it look in the Newman projection? Let's say that this is the H. Where is the VR going to be?
On the
Bottom.
On the bottom. If the H is here, the VR is on the top.
Mm-hmm.
It has to be in the same
Lane.
plane. Okay? So
Okay.
because I drew that like that, what is the product going to be? Draw the product. Concerted means the bonds being made and the bonds being broken are happening at the same
Simultaneously,
time.
right? Okay.
Yes, concerted means,
The
what does
bonds,
concerted mean?
the bonds are being broken and formed simultaneously.
You like fancy words. Huh? Okay, so what is this going to give me? It's going to give me a double bond here, yes? Yes or no?
Yes.
And there is something going towards the back.
Uh-huh.
That's a CH3.
Yeah.
There is something coming towards the front. That's an H. And this is
CH3.
CH3. And this is an H. That necessarily has to give you cis. Okay? Okay, what?
It doesn't necessarily, or it does necessarily.
It is necessary. By the way, this is, this nucleophile, yes?
Uh-huh.
The charge is not on the nitrogen, the charge is on the carbon. So when you make a bond, you are going to make it to the carbon and not the nitrogen, okay? That is a good nucleophile too. There's a problem here in the book that I'm going to find for you. So what's the product of any elimination?
Alkene.
An alkene. The fastest E1 reaction is for what type of alkyl halide?
Tertiary.
And the fastest reaction for an E2 alkyl halide is?
Primary.
No. No. Alpha.
Because in SN1 it was primary.
Because in SN2 it was primary, yes?
SN2 is primary.
But a primary, an alkene, oh, I forgot to talk about something else. That type of alkene is not very stable, yes? Yes? So in general, people have different opinions about this. In general, in E2, the fastest will be tertiary, okay? Now, if you have a tertiary alkyl halide here, it will either undergo E1 or E2, but they will both be faster tertiary, okay? So normally, on the test, I'm not gonna ask you a lot of questions, but primary is not the fastest in E2, okay? So provide the product for that. Now this is a somewhat of a difficult problem, okay? The reason why this is a difficult problem is because you just can't do an elimination there. I want you to do here an E2 elimination. Now this E2 elimination that you are going to do here, for an E2 elimination, what do we need to have? Anti-periplanar. It means that the hydrogen and the leaving group have to be on the same plane. Now how do you know which one is in the same plane here and which one is not? Do you remember how to draw cyclohexane chair conformations? Okay, draw it for that. And see which one is anti to that leaving group. The first chair conformation, make it the most stable. So this is 1, 2, yes? Where am I going to draw this isopropyl? Most days, equatorial. I'm going to draw it there. This is H. Yes or no?
Yeah.
Now the relationship of that to this is what, cis or trans?
Trans.
This is trans, yes?
So it's gonna go to
So
upper bond.
this is the lower bond. So the next one has to be the lower bond?
Oh, upper.
Upper bond.
Upper bond. Lower, upper. That's trans. What is that going to eliminate with? Can this eliminate with this?
No.
No. It has to be anti. It could eliminate with this one down here. Yes? If the bromine was here, it does an elimination and the double bond will be here.
Because it's on the same
But it
plane.
cannot eliminate with this one here. So what is it going to do? It's going to do, there is another bond there, yes? And another bond here, another there, another here. Those are close to this one. This is close to this one. That one is not so close, so it's not even close. Do a chair flip.
Professor, can you repeat why it wouldn't do the elimination at the top? I didn't catch it.
Because it has to be anti. You know what
What
anti?
has to be anti?
Huh?
What has to be anti?
The hydrogen and the leaving group.
Oh, okay. And right now they're both on the upper bond.
No, it's not about both being in the upper bond. It's about this
And I
one
don't
doesn't
see-
have anything that is anti, it's equatorial. There's nothing anti to an equatorial.
Okay.
Okay? Yes or no? Nothing is anti to an equatorial position. It has to be axial. You guys remember how to do cyclohexane chair conformations? That was too long ago.
No, yeah, you just you draw it the other way and then rotate one.
No, draw it in the same form as that. Okay? Yes? Okay. Wait a second. Okay, don't go crazy, okay? Let's draw it in the same way. So now I want to draw this here. Where's the other bond going to go? This is the H. Needs to be trans. Upper bond, the next one is going to be
Lower.
lower bond. So the BR is going to be here. Can it eliminate with anything on this side?
Yeah, because now it's on I'm sorry, it's axial as opposed to equatorial before.
Yeah. Now it's axial.
So
So it could eliminate, but is it with this one here? It can't eliminate with that, it has to eliminate with the hydrogen. So there's no way that this can make a double bond here. It cannot. It cannot make a double bond here. The double bond has to be made somewhere else. Now we have another hydrogen here and here. Is this hydrogen anti to this one?
is what?
Is this hydrogen here?
Yes.
The hydrogen here, the
Yes.
hydrogen here.
Yes.
This is axial and equatorial. Those are never anti. But this is axial and axial. Those are anti. So what is going to happen is the base is going to pull this proton off, and the elimination can only take place from that side. And when it does, what does it give you? It gives you where does it give you the double bond? Does it give it to you here?
No,
No, right.
No. It gives it to you where?
there. Yeah.
It gives it to you here.
Mhm.
Okay? It gives it to you between carbon, let's say 2 and 3 after it's eliminated. Guys, yes or no? Somebody has questions, or you guys are throwing a fit? You gotta have one like that on the test, I'm sorry. Whenever you see a cyclohexane chair, what happens? If it is an elimination, you have to be careful with what?
Where to place the double bond?
Where you place a double bond. The double bond, you have to redraw a cyclohexane chair. And the double bond has to go to the carbon that has a hydrogen in the axial position, and the leaving group is also in the axial position in the next carbon. Okay? Yes or no? You guys look so excited, it's unbelievable. I cannot believe you're excited. You can't believe mine either, can you? There is something called SICEF rule.
You mentioned it.
I mentioned it?
Yes.
SICEF rule says during an elimination, the more substituted double bond is the one that is formed. So SICEF says that if I have a choice, what double bond am I going to make?
The most substituted.
The more substituted one. So let's say I have something like this. And let's say that you perform an elimination here. Okay?
Okay.
The elimination with strong base, whatever base. Whatever base it is. I can put it on our console, I guess. What are the possibilities that we can have? We need what in order to have an elimination? We need hydrogens on what carbon?
Tertiary? Well, no.
On the beta.
Beta.
On
Oh,
the beta
beta.
position. Here's the alpha. Here's a beta, yes or no?
Yes.
And here's
That's a
another
beta.
beta.
Yeah.
I'm sorry, what was the difference between the beta and the alpha? The beta has the.
Like the
BR.
beta has the BR
The
actually.
carbon alpha.
I mean,
Oh,
the
the
alpha
alpha has
has
the-
the BR on it.
See like this?
The one that has the living group
Boom.
better.
That's
is the
alpha.
Okay?
You feel me?
Yes or no? Now, these are single bonds and it's not locked in place, so this can rotate whatever way they want until it's antiperiplanar. If it is an E2, if it's an E1, then it doesn't matter. So what can we do? We can form a double bond where? Here, from this alpha to this beta,
Okay.
yes?
Yeah.
Or we can also form a double
On
bond
the other
here.
beta. Yeah.
Yes or no? Okay? And if this thing rotated, it could form another double bond. This is trans, and this is
Cis.
cis. And both of those, cis and trans, are what type of substituted double bonds? Here's a double bond, carbon there, carbon here. That was a question on your test, wasn't it? Or no? No?
Yeah.
Substituted.
These two are di-substituted, and this is mono-substituted. So which one is a major product?
Dye
This is
substituted.
a major product. According to whose rule?
Zizef.
SICEF.
You're crazy.
That's major, this is
Mine.
minor. Conditions for eliminations are which ones? The use of a strong hinder base favors elimination, yes? Write it down. Elimination favored by a strong base. It's better if it's hindered. Eliminations are favored when when the reaction is heated. And heat is a delta, yes? Heat is like this, delta. So whenever you see heat, most of the time the product should be
Elimination.
elimination. Okay? Whenever you see such a base, you can expect this to be
Eliminate.
an elimination. Okay? Yes?
Strong base, heat,
Strong hinder base
strong hindered,
favors elimination.
hindered.
If not, what are you going to do?
Substitution.
You are going to do substitution if I don't tell you. You are going to do substitution and elimination.
Hinder, there's a, it's both of them. That's why you drew the T.
Yeah, the T is T-butyl, yes?
Yeah.
Guys, question about this. Questions? La Vista, you don't have questions? Why not? Okay, let's do one last.
Bless you. What are your attendance?
Professor, in SN1, since we have the possibility of rearrangement, we can do the methyl hydride shift if it leads to.
Okay, so what is this gonna give us? Gave you lots of choices, yes? No? What is it going to give you? Elimination or?
Elimination, yeah.
It has
Because of heat,
elimination.
yeah,
I would have given you this elimination,
yeah.
okay? Now, what do you look at when you're doing an elimination?
The hydrogen
The
that
base
is
and the
gonna.
hydrogen.
Where the
oxygen.
chlorine is,
Yeah.
or where the leaving group is,
The
which is this
alpha.
carbon here,
Uh-huh.
that's the alpha.
Yeah.
Here's a beta,
Better,
here's a
better,
beta,
better.
here's a beta. What do you mean better?
Better.
Okay, so what are we going to do? If we do this, is this beta and this beta the same?
Yep.
Yeah.
Yeah, this is a methyl group, this is a methyl group, it's the same.
Uh-huh.
And this is not the same. So
No.
I can have a double bond
It's
here, or I can have a double bond there. Yes or no?
Yeah.
Uh-huh.
So I'm going to draw first the
Yeah.
double bond here, and this would have this stuff and that. I drew the double bond here, it's gonna have a CH3, which is this, and it's gonna have that there. Yes or no?
Yep.
The other one is going to have
Yeah.
the double bond
At the bottom.
here. So let's draw that double bond,
Yeah.
and let's say it's gonna have a methyl and another methyl,
Right.
and yet another methyl. Which one is the major product?
The dye substituted.
The what?
Try or die?
That, yeah, that was
This is
try
tri
substitution.
Oh yeah, try.
Yeah.
substituted.
Substituted. Uh-huh.
This is a major product.
Major.
This is a major product according to
Zygzef.
rule.
You wouldn't need to draw the double bond to the bottom because it would be the same as the first one that you drew?
Yes.
Okay.
This is mine. This book doesn't talk about thermodynamic control and kinetic control, does it? I looked at it, I didn't read it.
Why do you got this substituted?
There's three.
Okay, when we talk about a substituted or a disubstituted, we're talking about the alkene, yes? Look, I covered it. How many carbons does it have on it?
Three.
Three. One, two, and three. That's called trisubstituted. You don't count these carbons, right?
Fine. I had
This, here's a double bond. What is this?
Now,
Disubstituted. It has those two. Okay? How you guys feel about that? The chapter is scary. And it's scary because when we did elimination, what happened? You were very happy until we started doing eliminations and you notice that everybody is competing with everybody else, yes?
Yeah, but it's good.
Because E1 competes with E2 and SN1 and SN2 compete and E1 and E2 and SN, everybody's competing, okay?
I'm pretty sure.
So, but there are some keywords, yes? E means what?
Elimination.
This is
Strong elimination.
so he likes to do elimination,
Yeah.
okay? Now, yeah. Other than that, I'm going to tell you, provide the substitution product or provide the elimination product.
Right. Hindered or bulky.
I'm tired. Oh, man.
Okay, you guys want